Welcome back to our class in chemistry. Today, we are going to continue our lesson on the nomenclature of inorganic compounds. Last time, we have already learned how to name the binary compounds. Today, let's have the ternary compounds. Now, when we say ternary, these are compounds composed of 3 different atoms. Now, there are groups of ternary compounds. One, we have ternary compounds which are named like binary. So, in this case, the cations are named by its real name, while the anion having the IDE ending. For example, we have NH4Cl. Now, NH4 is the cation which is a polyatomic because there are 2 atoms composing this cation. And the anion part here is the chlorine or the chloride. So the name is ammonium chloride. Another example is the NH4Cn. NH4 is the cation part and it is polyatomic, while the Cn is also a polyatomic anion. Since the NH4 is a cation, it is called ammonium, and the anion part, which is Cn, is called cyanide. So the name of the compound is ammonium cyanide. Another example is the sodium hydroxide. If you're going to look at the sodium hydroxide, there are 3 atoms composing it. Although it is a base, but this could be a good example of a ternary compound. The sodium is having the symbol Na, which is the cation, and the anion part here is the OH, or it is called hydroxide, or the hydroxyl. NaOH is called sodium hydroxide. Another ternary compound is the ternary acid. When we say ternary acids, these are acids that contain hydrogen along with oxygen. And there is the central atom. Now, in naming these ternary acids, the name is dependent on the name of the central atom. So, we have to base the name of these ternary acids by the oxidation number or oxidation state of the central atom. If the central atom has an oxidation number of 1 or 2, then there is a prefix to be used, which is hypo. Then add the stem name of the central atom and ends with an OUS ending or OS. So you have it there, hypo, then the stem name and the suffix OS. If the central atom has an oxidation state or oxidation number between 3 and 4, there is no prefix to be used, but there is the suffix to be used, which is still os. So the name of this ternary acid will be the stem name plus the suffix os. But if the oxidation number of the central atom is between 5 and 6, there is no prefix to be used, but still there is a suffix, and this time it is ic, or it ends in ic. So the name of the ternary acid will be the stem name ending in ic. If the oxidation number of the central atom is between 7 and 8, there is a prefix to be used, which is hyper or per, plus the stem name of the central atom, then the suffix ic. So the name of this acid will be per plus the stem name ending in ik. Let's have a specific example. For example, the acid HClO. So if you're going to look at it, there are 3 atoms composing the acid: the hydrogen, the chlorine, and the oxygen. The central atom of HClO is Cl, or it is chlorine. Now, if you're going to compute the oxidation number of chlorine, which is the central atom, there is an oxidation number of 1. Why? Because if you're going to write the formula, it is HClO. We know that the charge of hydrogen is +1 and the charge of oxygen or oxide is -2. So, to make a total charge of the HClO to be 0, because we know compounds have 0 charge, so the charge of chlorine must only be +1. So hydrogen +1, chlorine +1 is +2. Plus -2 equals 0. So we can see that the oxidation number of chlorine is +1. And I said a while ago that if the central atom has a charge between 1 and 2, there is a prefix which is hypo plus the stem name. This time it's chlorine, so it is chlor, and it ends in os. So the name of this acid is hypochlorous acid. Suppose we will increase the oxidation number of chlorine. This time, we have the formula HClO2. So if you're going to compute the oxidation number of chlorine, there is an oxidation number of +3. Why? Because the oxygen now, or the oxide, has a charge -2 times 2, so it is -4. And we know that the hydrogen has a charge +1. So the difference is +3. So this +3 must go to chlorine. So if the oxidation number of the central atom is between 3 and 4, there's no prefix to be used. You just go directly to the stem name, which is chlor, and it ends in os. So the name of this acid, HClO2, is chlorous acid. If we're going to increase the oxidation number of the central atom with this formula, HClO3. So in this formula, we can see that the chlorine will have a charge of +5. Why? It's because the oxygen has a subscript 3, then multiply it to its charge, which is -2, so it makes -6. Now hydrogen has a charge of +1, so what must be the charge of chlorine? In order to make the charge of the compound 0, so the chlorine should take the +5 charge. So, I said a while ago that if the charge of the central atom is between 5 and 6, there is no prefix yet to use, but you have to use the stem name, which is chlor, and this time it ends in ik. So the name of this acid now is chloric acid. Suppose we are going to increase the oxidation number of the chlorine by having the formula HClO4. If you see in the formula, the oxygen has a subscript 4. So that 4, if you multiply that to its charge, which is -2, the oxygen will have a charge of -8. So what must be the charge now of chlorine? Because the hydrogen is only +1, therefore the chlorine must be charged +7. And I said a while ago that if the charge of the central atom is between 7 and 8, there is already a prefix to be used, which is hyper or per, plus the stem name, plus the ic ending. So this time, the HClO4 is called perchloric acid or hyperchloric acid. Another good example would be the H2SO4. Now, H2SO4 is composed of 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. We know that if there is a subscript 4 to oxygen, you multiply that by -2, so it makes -8. However, the hydrogen has a subscript 2, so the charge of hydrogen is 1. Then multiply it by 2, so the hydrogen will have now a total of +2 charge. What is the difference between 8 and 2? So the difference there is 6. Where lies this 6 oxidation number in the table? This is when the oxidation number of the central atom is between 5 and 6, there is no prefix to be used. You go directly to its stem name and it ends in ic. So the stem name here is sulfo or sulfur plus the ic ending. Therefore, the name of H2SO4 is sulfuric acid or sulfuric acid. Another example is, if you have H3PO4, now the central atom here is phosphorus. Notice that in the formula you have hydrogen has a subscript 3 and the oxygen has a subscript 4. So 4 times -2 is -8 and hydrogen has +3. So what must be the difference between 8 and 3? That will be the charge of the central atom. So the difference is 5. So what must be the name of this ternary acid if the central atom is 5? There is no prefix. You go directly to the stem name, which is phosphor, and the suffix is ic. So the name of this ternary acid is phosphoric acid. That is your H3PO4. Another group of this ternary is the base. We know that the base is mainly composed of a metal plus the hydroxide or the hydroxyl ion. Now, these are ternary compounds. What have you remembered of a base? A base has a bitter taste, while the acid is having a sour taste. Now, how are we going to name these bases? The cation, which is the metal, will take its metal name, while the hydroxyl or the OH will take the IDE ending. So in the case like NaOH, so this is called sodium, and the OH is hydroxide. So the name of the compound is sodium hydroxide. Another one. Suppose we have the MgOH2. Remember the charge of magnesium is +2, while the charge of the hydroxide is -1. Let us try to recall. The charge of the cation will become the subscript of the anion. So the charge 2 will go to the hydroxide. So that's why the formula is MgOH2. The cation part is the magnesium, but the anion part is the hydroxide. So the name is magnesium hydroxide. Another one. Suppose we have AlOH3. So the Al has a charge positive 3, while the hydroxide has a charge of negative 1. Exchange their charges to become the subscript, so you have the formula AlOH3. So what must be the name of this compound? It is called aluminum hydroxide. So those are some examples of ternary compounds. Let's go now to naming the salts. Now, what are these salts? Of course, there are salts which occur in nature, like the sodium chloride that you can find in the seawater, the magnesium chloride, which you can also find in the seawater, the calcium chloride in the seawater. The seawater is composed mainly of the sodium chloride. Now, salts, if you're going to synthesize this, is a product formed between an acid and a base. That's why if you're going to react hydrochloric acid with sodium hydroxide, you can get the salt sodium chloride. But this sodium chloride that you have synthesized is not safe to use, by the way. Only the naturally occurring sodium chloride is safe to use. That's why you call that the table salt. But the synthetic one, please do not use that. For these salts, we have one, the binary salt. Now, this binary salt is composed of only two kinds of atoms. You have the metal part and the non-metal part. Like naming the binary compounds in our first lesson, we have to name the cation metal by its metal name and the anion ending in IDE. So for example, if we have the salt CaCl2, meaning calcium chloride, okay, when you write the formula CaCl2, why? It's because the Ca or the calcium has a charge +2, while the chlorine has a charge -1. So exchange of charges to become the subscript. That's why the formula is CaCl2. And the name of this salt is calcium chloride. Another example. Suppose we have the salt AlF3. What is this? Al is aluminum having a charge of +3. F has a charge of -1. So exchange of charges to become the subscript. So we have AlF3. And the name of this compound is aluminum fluoride. Another is, suppose we have NaI. Sodium, which is Na, has a charge of +1. Iodine, which is -1. Exchange of charges to become the subscript. So we have Na1I1. What did I say last time? I said that if the subscripts are all 1, you may not write it anymore. So the formula is NaI. What's the name of this salt? This is called sodium iodide. Then let's go to the ternary salt. Now, these are salts which are composed of 3 different atoms. Usually, the anion part is a polyatomic ion. For example, we have Na2CO3, or this is sodium carbonate. So, we have here the cation, which is the metal part, is called by its metallic name, while the anion takes either the ITE ending or the ATE ending. It depends again on the oxidation state of the anion. And the case like sodium sulfite. Now, The SO3 here, which is the sulfite, has a charge of -2. The sodium has a charge of +1. Therefore, the formula of sodium sulfite is Na2SO3. Another is, if we're going to use the sulfate, sulfate is a polyatomic ion which is SO4 with a charge of -2. And then pair this with the cation sodium, so the formula becomes Na2SO4. Now, the sulfate has a higher oxidation state as compared to sulfite. So, the name of the ternary salt is sodium sulfite. Another is the magnesium carbonate. Magnesium has a charge +2, while the carbonate has a charge -2, exchanging charges to become the subscript. So you have Mg2CO32. And since their subscripts are the same, you can cancel it out. Reduce to its lowest term, it becomes Mg1CO31. And what did I say last meeting? I said that if the subscripts are all 1, you may not write it anymore. So, the formula becomes MgCO3. And the name of this ternary salt is magnesium carbonate. The third group of salt is the mixed salt. In the mixed salt, they may exist as having 2 cations with 1 anion, or 1 cation with 2 anions. In the case of the mixed salt that contains 2 cations with 1 anion, the general rule is that you are going to write the cation with the lower oxidation state first, then followed by the cation with the higher oxidation state, and the anion will be written last. For example, in the case like potassium aluminum sulfate, potassium has a charge +1. Aluminum has a charge +3. Sulfate has a charge -2. Now, if you're going to get the total charge of the cations, there is a total charge of +4. And the anion, which is sulfate, has only a charge -2. I said in the previous meeting that there will be an exchange of charges to become the subscript. Now, where will the subscript of sulfate go? And where will the total charge of potassium and aluminum go? Now, the charge of sulfate will go to the first cation. So it goes to K. While the total charge of K and Al, which is 4, will go to the sulfate polyatomic anion. So the formula now becomes K2AlSO4 4. Okay, repeat. K2AlSO4 subscript 4. Now, you notice that the subscripts 2 and 4 are reducible if you're going to divide this by the factor 2. So, if you divide the subscripts by 2, the subscript of potassium now becomes 1, and the subscript of sulfate is 2. So, the final formula of potassium aluminum sulfate is KAlSO4 2. So that is read as potassium aluminum sulfate. Another example is that of the LiCuPO4. Now, Li, which is lithium, and Cu is copper. And the phosphate there is a polyatomic radical or a polyatomic ion. The Li has a charge +1. The copper taking the +2 charge as cupric will have a total charge of +3, while the phosphate as an anion is having a charge of -3. So exchanging of charges to become their subscripts, the +3 of the total charge between lithium and copper will go to the phosphate polyatomic ion, while the -3 charge of phosphate will go to Li. So it will look like this: Li3 Cu PO4 3. Take note, the charges are the same. Now, because they are the same, they are reducible into 1 by dividing it by a factor of 3. So, the subscripts will become Li1 Cu PO4 1. And I said that if the subscripts are all 1, you may erase it out. So the final formula of this mixed salt is LiCuPO4. And the name is lithium cupric phosphate. Another group of the mixed salt is that one wherein there is 1 cation and 2 anions. How are we going to write the formula of this mixed salt? The general rule in writing the formula of this type of mixed salt is that, of course, the cation is to be written first, then followed by the anion with a higher oxidation state, and the anion with a lower oxidation state is written last. For example, in the case of BiOCl, Bi here is bismuth with a charge of +3. O is the oxide with a charge -2, while Cl is the chloride ion with a charge -1. So if you're going to look at the charges, bismuth has a charge of +3, and the total charge of the oxide and the chloride is -3. Now, where will these charges go? That of bismuth will go to the chlorine as a subscript, and the total charge of oxide and chloride, which is also -3, will go to bismuth. So if you're going to look at the formula, it will look like this now: BiO-CL3. Now, because they have the same subscripts, if you're going to divide it by a common factor, which is 3, so the formula will become Bi1OCl1, or it is BiOCl. And what is the name of this compound? This mixed salt is called bismuth oxychloride, or bismuth oxide chloride. So those are some examples of the mixed salts. So today I have already discussed the naming of the ternary compounds as well as naming of the salts. Since I have already done discussing this whole chapter on the nomenclature of inorganic compounds, so I will give you an exercise first before a quiz. So kindly view and answer the exercise that I will be sending you today. That would be all for today. This is your teacher, Professor Nisitas Ruiz of Holy Name University.